1, 2, 3, go.
Good afternoon. Today we're here with Sir Pau biologist extraordinaire, and we're here to talk about mutations. More specifically, human mutations.
You don't have to whisper it.
Okay. More specifically, human mutations. So, sir, what are examples of some human mutations that have come out over the course of time?
Okay. Well, mutations usually they're entirely random. But the more advantageous ones are, I think we discussed this before. Some mutations can actually provide immunity to diseases, to other diseases, some diseases. Sorry. Anyway, yeah, some diseases, as a cause of mutations, can provide immunity to other diseases. Like, for example, survivors of the bubonic plague, right? The descendants are immune to HIV. So the virus will not bind to the cell membranes because of a mutation that was caused by the bacterium, Yersinia pestis. So it's been found that in a lot of European populations, they're immune to HIV. And then there's the case of cystic fibrosis. There are also mutations there that provide immunity to malaria. If I'm not mistaken, it's malaria. In terms of other mutations, I actually read this journal about some scientists agree that there's actually a gene for athleticism. So the people who have this gene are found to be not more athletic, but they're found to have higher stamina. Their muscles tire out less, at a slower rate as compared to other people who don't have this gene activated.
So this gene is also a product of mutation.
Of course. Yeah. But not all people have it. So yeah.
So would you say that in the future that mutations like this would be more prevalent in society? Like there would be more mutations and cause greater variation?
Okay. Well, mutations are random, right? But there are also agents for mutation. Like for example, ultraviolet light. There are chemicals that can cause mutations. So in recent times, actually, pollution rates have been increasing steadily. So there are actually substances in our air that can be considered mutagens. So yeah, if that keeps up, then we can say that mutation rates can get higher. But then, like what we said, mutations are random, so we can't pinpoint one mutation happening in a global scale. Another cause of
so
mutation.
When people mutate, it's not a uniformity. It's something random. Person to person can be different.
Yeah. It depends on what that mutation has targeted. So another cause would probably be UV light, and UV light is usually filtered in our atmosphere, right? But the ozone layer is steadily thinning out. There are holes in the ozone layer. So if this keeps up, then more UV light can pass through the ozone layer and get to us. And if that happens, then mutations can also...
Like what kind of mutations are possible?
Well, cancers. Some cancers, yeah. Really depends.
But mostly disease-based.
Many can be disease-based.
And others. Are there different kinds of or classifications of mutation?
There are mutations that can't really be seen. Yeah. There are some
like
that...
the gene of athleticism? Something like that.
Yeah. It's not something that is visible, right? So yeah, it really depends. Some can cause diseases, of course. And those are the ones that we have to take note of.
So basically, what you're saying is, in the future, possible mutations for humans might be things like diseases or differentials in their body or anatomy or morphology.
Yeah, that's possible.
When people talk about mutations, like a lot of the time, you have questions like the X-Men, other mutants like that. Is that a possibility as well?
Well, am I gonna talk about X-Men here? Well, in X-Men, That's why they're called X-Men, diba? Because the mutation is found in the X chromosome. So, if the mutation is found there, it is possible, but I don't think it's possible for anyone to fly without wings or like
Archangel's possible.
if we develop wings, but his wings aren't, actually possible because evolutionarily their wings, the bird wings, for example, are derived
Hollow,
from
dapat,
and they're derived from limbs. So Archangel's wings are at the back, so it should be his arms that are the wings. Yeah, but if there are enough mutations, who knows? Diba? But too many mutations can make the genome unstable.
So what happens if the genome's unstable?
It also depends. If it's too unstable, it's not naman unstable that it entirely breaks down or it falls apart. But if the genome has too many mutations, sometimes the organism won't even develop embryonically properly. So before birth, the organism dies.
So basically, like the mutations like X-Men or super-powered mutants aren't so much possible on the more extreme scale, but maybe like a bit stronger, a bit faster.
Yeah, but I wish it were true.
Yeah, I wish it were. Like, I won't be able to shoot laser beams out of my eyes, but I'll get better eyesight, like something like that.
Probably better eyesight, but not laser beams
beams
out of your eyes. So, yeah, because there are also organisms with very, very good eyesight. For example, raptors, right? They have very good binocular vision. So if we get a mutation that allows us to have that kind of binocular vision, I don't know how many mutations that will take. You have to take note that one mutation will not usually dictate a change, diba? In the phenotype or in the the expression in the organism. So sometimes it can take many mutations or take many different genes to do that. So yeah, it can be possible, but
it's a long way.
Yeah, laser vision, it's physically not likely. Not likely.
More like storm powers.
Storm powers, controlling the weather. If you can control the ions in the atmosphere using your electrical charges in the body, I don't know how you'll do that. But then maybe you can be able to.
Okay. Thank you, sir. That's all the time we have for today. Please join us again next time. Thanks, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.